November. It's about 3 o'clock in the afternoon. What I'm doing is I'm doing a preliminary setup of the scope that we're going to be using in order to monitor the transit of Mercury across the face of the sun tomorrow morning. We are not in the best location for this. The transit, the best place to be right now would be the East Coast, not the West. We're in Oregon. But the idea is on the East Coast, the transit will occur for about 5.5 hours. And it'll start a little after sunrise and last till 1:04 or 1:05 in the afternoon. There was a transit 4 or 5 years ago of Mercury, but the next one's not for the next 12 or 13 years, so this is the last chance to see. And for a while, Mercury basically shadow cast against the Earth from the sun. Of course, it won't be like a solar eclipse where the whole sun is blotted out by Mercury, because Mercury is a little larger than the moon, but maybe as much as, quick calculation, 250 times further away than the moon at this point. Although Mercury will be as close to the Earth as it will get in this particular cycle. Basically what you got to do with a telescope is you're never going to look at the sun through a telescope. Not even through the finder scope, by the way. The smaller scope here would still burn the heck out of your eyes. In fact, you shouldn't even look at the sun at all with your naked eyes. But we're going to use a special method called eyepiece projection. What you need is a piece of white cardboard or something that you can throw the image of the sun against from the telescope. The funny thing about setting up the telescope, though, is since you can't point the telescope very easily at the sun, because you can't look through anything, you have to use a special method of shadow casting of the telescope, especially the finder scope. Unfortunately, right now, the sun is behind a cloud. So this is the first time we've set this refractor up here in Oregon. It was originally set up for Arizona. One of the first things I'm going to do is I'm going to dial in the basically the latitude here. We want this scope in order to be able to track tomorrow as the sun moves. I can turn these various knobs and I can do a job of tracking the sun's motion as the Earth spins. So what I'm going to do is I'm going to set it up for our latitude right now, which is basically about 44 degrees north latitude. And assuming all these legs are level, I found a relatively level spot to do it, then this thing will more or less track manually as the sun moves across the field of view. So what I've done is, I know our house is relatively oriented north-south, so basically I've come over to, right, you see the line of the roof line there? I know from experience that pretty much points towards Polaris, and since we can't see Polaris during the daytime, I need to have some kind of reference to get the scope properly aligned. We all know that we live on one of what most of us agree are 9 known planets in the system. Sorry to those who try to exclude Pluto, but its orbit is so massive that there's no way it was ever going to sweep all the material, because it's several billion miles out away from the sun. So Pluto is a planet. There's 9 we know about. The moon is not one of them. So there's, of course, the innermost planet that we know about, which is Mercury. That's the planet that's going to transit tomorrow. It's fairly close to the sun. It'll take it about 5 hours plus to move across the face of the sun, and the sun's about a half a degree in size, in terms of apparent size from Earth. So it'll trace a half a degree of the sky in about 5.5 hours, which is well less than a day. The next planet out is Venus. Mercury is not the hottest planet in the system, despite being the closest to the sun, because Venus has a serious heat-trapping atmosphere, and its temperature is hot enough to melt lead all over the planet. And unfortunately, that's the direction we're heading with the Earth right now, because we are emitting the kinds of gases that trap the sun's light against the body of the Earth in its atmosphere that could potentially lead to the kind of thermal runaway that Venus is experiencing in our system. You can see the sun drifting towards the 1 o'clock position. That indicates the direction of the sun's motion. And you can see that the planet is basically moving in the same direction as it gets closer to the limb. Let's say it's about 3/4 progressed now. Given the fact it's 9 o'clock, we have about another hour and 5 minutes of this, so we have 2 more checks. Okay, backing out. So the Earth is located about 93 million miles from the Sun. It's actually a fairly circular orbit. It only changes by about 1 million miles. The next planet out, Mars, however, on the other side of the asteroid belt, which is not, there's no planets in the asteroid belt, has a fairly elliptical orbit. It gets closer to the Sun by about 15 or 20 million miles. I don't have that information memorized. And it goes further out. So it gets out about 143, 145 million miles from the Sun. Mars is an interesting study. Early on, it was a living, dynamic planet. It had all kinds of tectonic activity. We now know there's water on Mars. It's highly probable there are primitive life forms on Mars. We have already discovered some of those life forms as remnants inside of rocks that have been hurled at the Earth after Mars was struck by comets and asteroids. So we know at some point, regardless of the science right now, we have a pretty fair notion that life formed on Mars at one point. Why? Because everywhere from Venus through the Earth to Mars, all were part of what is called the Goldilocks zone, where liquid water could take form. And life, it seems, is so powerful a phenomenon in the universe that wherever it can take form, it tends to take form. And besides that, life spreads itself throughout planets and things because there are life forms that can survive the vacuum of space as they travel through it. So if you strike a planet with a comet one place and rocks are hurled off, they will end up in other locations as well. It is now 9 o'clock. There's another hour and 5 minutes left. And it looks like from this position we should be able to get the sun without it going into a tree again. You can see boiling at the limb of the sun a little bit in the camera. That's due to the atmosphere. Atmosphere is heating up, it's moving around, and therefore it gives that effect of changing the sharpness of the sun's limb. Fortunately, Mercury is large enough that it's resolvable to some degree. You got to realize Mercury is about 3,000 miles in diameter, and it's probably 50 million miles away from us. The Sun is about 1 million miles in diameter, and it's 92 million miles away from us in the winter. This is probably the best we're going to do as far as focus is concerned. What you want to do is just get the shade. See how the shade progresses across the screen? You want to get the shade progressed across the sun, and that makes it as flat as it can be.
Blend it out.
Yep. Right there. Beyond the orbit of Mars, which is the 4th planet out, you have the gas giants, you have Jupiter, and you have Saturn, and you have the fairly large planets of Uranus and Neptune. These planets are all fairly large and massive, much greater than the size of the Earth or the inner planets, and they are commensurately further out, so they move much more slowly. It takes Jupiter about 12 years to complete an orbit around the sun. Compare that to the 80 days of Mercury or the 1 year of 365 days of Earth. And then you get out to Saturn. It takes about 8 years to orbit the sun. So these things are moving slower and slower. Then you get Uranus and Neptune and eventually Pluto, which has about a 250-year period of cycle going around the sun. So there are probably large objects in space the size of Pluto or larger further out in the orbit of Pluto. We call them Planet X. Sooner or later they'll be detected, but they're very faint and slow moving, hard to find. So our solar system is a fairly complicated one, and it has 3 planets, as I've already mentioned, in the life zone associated with the sun. Coming up on 9:30, gives us 35 more minutes of the transit, more or less. Once again, the Earth's been relentlessly spinning. Going to have to track down the sun again in the eyepiece. Let's check the focus. It's not supposed to disappear until 10:04 our time. And maybe it was just a spot on this board. Look at that.
It was pretty progressed when we went in half an hour ago.
This is odd. So apparently in the last half hour, oh, there it is. You see it? Right there. That's peculiar that we lost it for a second.
Phew.
Because it wasn't visible there for a little bit. See that? That was really odd. Maybe there was like a little bit of a cloud there or something that was masking it out. Either that.
Okay,
Or
point
Mercury is so fast that it managed to shoot off till I get a cup of coffee somewhere and then came back where it's supposed to be, right there. You see it? But there it is.
It is
And
fainter.
we're very close. Well, now, you know, slightly
Right.
more of Mercury is being illuminated because it's
Right.
not directly in alignment anymore. But that's not enough to account for why we couldn't see it initially. It must have been some kind of atmospheric phenomena. But there it is. It's so tiny. Venus was so obvious when we saw it. And yet, really, looking at Mercury, it's no larger than what I've seen in terms of sunspots. Sunspots on the sun can be like 5,000, 6,000, 7,000 miles in diameter, but they're on the sun, so they're further away, so they look smaller. But that looks like a sunspot.
So cool. As they say, everything is in motion.
Everything is in. Oh, you can see a cloud drifting. See that?
Oh, yeah.
Yeah, that cloud drifting over. So maybe that's it. We got some atmospherics. Yep, there's the clouds drifting over it. While it's possible to see Mercury transit the sun and the moon, which ends up in an eclipse, it's also possible to see Venus. And Venus had a transit about 2013. They don't happen very often either because Venus's orbit is much larger. Okay, this should be our last view. That's it. You can see the clouds drifting against the solar disk. It's not a perfectly transparent day. The transition is supposed to conclude at 10:05, but that was based on at 1:05 East Coast time, which would be 10:05 here in the Pacific Standard Time. But I'd say it's going to take a little more than 15 minutes. We're 15 to 20 minutes, maybe a half an hour. But that's a pretty good view. The big issue with transits is you got to get everything to line up just right. Just like with a solar eclipse caused by the moon, you have to have everything on the line of sight. So therefore you got to have something like, you got to have the sun, and then you got to have the Earth, much smaller, and then you have to have a perfect line between the sun and the Earth in order to see a transit. I lost my little black dot. Okay, so to reprise, this is pretty much, you see that little black dot in the middle of the sun? It's about the same size as Mercury. It's not Mercury, but watch. Mercury started right about there, and then over the last 5.5 hours, it drifted across the face of the sun, like this, in its motion. And now, if I put the black dot right over the top of Mercury, you can see it right there. And then it's going to exit. So that's the fast rewind view of a Mercury transit. And of course, the planet that transits has to be inside the orbit of the Earth. Mercury's about here, and Venus is about here, and the Earth's about here. So that gives you a relative sense of their distances.
Is it gone now? Or no?
No, I made it go. I can make it disappear. Look, if I go like that. It's gone! Mercury must have made the transit. No. It's just the scope is the Earth's spinning really quickly.
Well, I feel really fortunate we have the time off to do this.
Yeah, well, that's
and then show others.
And the equipment. Well, I'm going to ask anybody out there, would it be possible to see the transit of Mars across the surface of the Sun, or Jupiter, Saturn? What do you think? You'll have to work that one out for yourself. We're about to lose Mercury. Is the image sharp in the camera? Because you're really close. Well, I would say that's about it. But once again, I'm going to do this little thing with a little dot. Look over there. I'm going to do this little thing with a dot, and this is the way it transited. It started about there, went across the face of the sun, like that, and after a 5.5 hour period, a revolution.